Hey, welcome back. Steve Basic Architect here. Yeah, we are back in studio. Today, we're going to talk some details out on that passive house that I did, I don't know, upwards of 14 years ago. So we're going to look at them. I'll be sure to mention some of the things that I would change. I've probably gone through about 6 generations of details since I actually drew these. But you can understand a lot of the principles back then. Same principles today, just do it a little different. There's materials that have come online and that I found that help the situation a little. So let's get into it. First up, windowsills. You know, I'm Steve Basic Architect. I'm a contributor on the Build Show. If you're familiar, buildshownetwork.com. Go check it out. And of course, this is the vibe board, all fired up, ready to go. So there's the house. This one, construction sequence, got tons of construction photos. Remember, refresh your memory on this. This house here I designed in, let me get a little thicker pen here for you, 2009. We constructed it in 2010. And yes, it is a passive house and it's certified. Yep. I think it was like 5th in the nation when it got certified. So it was definitely one of the very, very first that passive houses that we put in America. So a couple things to notice here, all right, when we're talking about windows before we get into the actual details. Notice on this one, all of these windows are heavily protected. Right? The roof cuts around the corner, even the door has a little space, and then of course, all of the second floor windows, all protected. Protected from rain, right? But one other thing of note in this photo, notice there's 2 types of what I would call window settings, right? So here, notice all of these windows are somewhat in the same plane as the wall. So I would call those outies, right? And notice up here, we actually have some dimension there. So you have the wall and then it goes in on the windows, and you guessed it, that's an innie, right? So we have innies and outies, and we have those 2 details that we're gonna compare. So quick shot, this is just the interior. Notice we have 14-inch walls here, right? So 14-inch walls, those are probably yielding not a 14-inch sill. That's the wall. The sill, if I had to guess, is probably somewhere on 11 inches. Well, we have a little overhang there. We'll call it 12 inches, 12-inch sill. And this, of course, is the outie, right? It's pushed all the way back to the outside plane of the wall. And then over here, make this a little bigger, you can see, I can see a little wall there, and there's a little wall here. So this one's somewhat in the middle. I mean, we could call it a midi. I don't want to get wrapped up in semantics here. For our purposes, we'll just call it an innie. And you can see this windowsill now, that's probably somewhere around 8 inches finished. So we diminished it, basically moved the window in about 4 or 5 inches on that scale. Don't do the math and tell me how I was actually wrong on the math. But here's the windowsill details. And we'll start on the lower floor, because the choice was on the lower floor to do the outie, and then as we moved up, we pull the window in. I wanted to get upstairs, we had the shake, if you remember the photo, and I wanted to get those shakes to turn the corner nice and neat. And then downstairs, we would have all of our trim and window in the same plane. So here you can see, and don't ask me who the window manufacturer is. I forgot the name. All I do know is they were not a very good window manufacturer, and they're out of business, so the name really doesn't matter at all. They went out of business probably about 5 or 6 years ago, I heard. But they built an exceptional window. Their service was absolutely horrendous. We had to wait probably an extra 8 or 10 weeks to get these windows. But also you got to remember, this is 2010, triple glazed windows coming down from Canada. I mean, it was probably, you know, a handful of projects that has happened to before that. We were probably the first or second project that this company had to deal with, shipping windows across the border. So, you know, one of my favorite lines, first ones through the wall always get bloody, right? So notice here, if you've been following along, if not, go check out all of the previous videos. It's a double wall construction, right? 2x6, 2x4. That makes up 9 inches. And I want to say we had something like about 5 inches, somewhere around there, in there. I forget exactly what the thickness was on that wall. But also notice that our sheathing here came all the way up, and our sheathing went all the way back, right? And we needed to do that because if we had fire coming up through here, we needed to be able to stop it on that double wall construction. So you have to compartmentalize it. Not that the sill or that wouldn't do it, but if you have it come up, then it gets in all these other channels and the fire can spread. So we just closed it off. Plus, you have to insulate it. So in insulation and blowing in cellulose, you also want to, you know, we have to provide some kind of lid because the sill and the window aren't there when the insulation is going in. So those are there. A couple things to call out. Notice we have a bead of sealant here, and that's to seal our sheathing to the frame. And then we also have a bead of sealant there. And basically what we're doing is we're making the connection from our sheathing to that bead of sealant to the frame to that bead of sealant to that plywood closure piece. And then we also have this membrane that comes out over the top there. And that membrane is also sealing this joint. But this connection through there gives me something now to attach the window frame, right? You know my favorite word when it comes to air sealing, continuity, right? So we basically take our weather resistant barrier, or in this case, I would call it my primary air barrier, and basically just fold it into the opening, right? When you use a house wrap, for those of you that have installed using house wrap, you cut it, you fold it into the opening. Well, that's all we're doing here. We're just doing it with a OSB panel, zip panel in this specific case. And then grab a new pen here, grab a green one. Notice this window, because it's an outie, it actually has a flange. And the flange goes out over that membrane, and that membrane turns up. We have a back dam, right? And the back dam is, sole intention is, if any water comes down into the system, it's going to collect in this back dam, and it's not going to have the ability to traverse into our wall system, back of the drywall on the wall, create mold, all of those good things. It's at the right temperature. You got water activity and the food source, the paper-backed gypsum board. It's a great food source for mold. So anyways, windows, they get installed, plumb, all of that stuff. And then notice we would put a backer rod, we called for it, there, and then we would put a bead there and or expanding foam on both sides of that. Now, we would do things a little differently. I'm sure you've seen some of my window install details of today where we would likely just simply tape that on the inside. We'd push this back dam up far enough so that it actually would come down and go on top of the back dam. And if we were doing a face sealed system, then we would simply tape that flange on the outside. We'd probably do some expanding foam. I wouldn't have done the backer rod and then two runs of the expanding foam. We'd just do one really close to this inside edge if we were to do it today. But you know, the nice thing about this window company is that in opposition to our typical tilt turn windows of today that we use, because this is an actual swing out casement, the insect screen is on the inside and you can get blinds down here nice and easy because the window goes out of plane and the outside, not on the inside. The risk here, you know, a couple things. Pushing that window all the way out to this outside edge here, that's really good because I minimize any water intrusion in this area, right? Because I don't have much of a sill there that puts me at risk. The one risk that I do have is if this is a relatively small window and I am in an extremely cold climate, I mean, maybe climate zone 5 could have some bad days, but definitely climate zones 6 and 7, I get that heat rising or delivered from the floor and it doesn't really get all the way, doesn't get all the way in here to warm that inner surface. Oh, it's right there actually. That inner surface of the glass. And so because of that, I could create what's called a microclimate inside here, that because that microclimate doesn't quite get enough energy in there to warm the glass might be 2 or 3 degrees colder than it would if the window was more in the middle of the wall. And that 2 or 3 degrees could certainly be the difference between vapor staying vapor or vapor condensing into a liquid form. So I'm always cautious when I push the windows all the way out to the outside. I really want to make them large enough. You know, if this was like a 2x2 porthole that went through there, I think we'd be at a high risk. But these windows were, I don't know, probably on the order of about 32, 36 inches wide and probably close to 6 feet tall. So having that larger expanse of glass, I have a better chance of getting that heat energy up against that interior pane of the triple glazed piece of glass there. Let's take a look at what happens when we do move that in, right? So continuing that discussion, heat, and when I say heat, you know, register heat energy that we're paying to heat the room. It can go up. This is a lot closer here in the opening than when that piece of glass was, say, out there, right? So that engineer or energy nerds, if you will, if you ask them where's the best place to put the window, they're going to tell you the middle third is likely the best place to put it from an energy perspective. It gets the glass warm enough, but it doesn't put you at that much of a risk. Now, understand, if you're in climate zones 3 or 4, then that risk also kind of goes away, right? So it doesn't translate as well as it does, say, in climate zones 7, if you're up in Minneapolis or northern Minnesota. But pushing that window back, it also does something. It exposes more sill, right? So now you can see my membrane goes all the way out there and covers over. And that membrane now has a lot more exposure. And the more I expose that sill, the more rain it's going to see. The more rain it sees, the more it gets challenged. The more it gets challenged, the more it gets worn down. The more it gets worn down, the higher risk I am at rainwater penetration. And what do I always say about water? You know it. Number 1 killer of buildings is water. But we push the window in. Notice there is no nailing flange on this. These are flangeless windows. It was my first, I think it was my first experience ever using a flangeless window. So there was some new things to me here. But notice the window got installed. I believe this one got installed with some installation clips. But our detail here was pretty much the same. We did a giant backer rod, and then we did some foam sealant on the outside and foam sealant on the outside there, and you can see it's pretty much almost centered in the wall there. And you know, finding the right material for this sill certainly became a challenge. Nice big board as a sill on the flat, sun's beating down on it. You know, when the sun beats down on things, very much like our body, if I lay in the sun, I burn on this side, the back side stays very well protected. Well, boards here are exposed to UV and the heat of the sun on the top side, but the bottom side is protected. So a lot of times, you know, you get some boards that want to go wonky like that, that want to significantly dry up and curl. So you have to really pay attention when you get these larger sills. Now, working with Schuco and some of the Euro companies, they actually make a metal sill that can be integrated here and basically screwed into the window. So we can take that out of the picture there. And then lastly, on the windowsill, notice one of the things that I do now that I didn't do here, and again, we're all learning. I'm exposing my personal learning curve here. Notice this is perfectly flat. If I were to do that today, you know, I would put in a piece of lap siding or something, but I would create some motivation to move the water. Right? If water gets in there, I want to push it down into that rain screen space, right? I don't want to leave it sitting underneath the sill. Now, is it a problem? I don't think it is a problem. The house has been down there post construction. It's performing exceptionally well. So I don't think it's a problem. You're going to get water in there. It's going to sit on the membrane and it's just going to dry. The sun's going to come out. It's going to dry it up. There's nothing in there really for it to harm. So, but that being said, if I was doing it today, I'd provide a motivator and I'd get rid of that water. So anyways, there you have it, folks. I'm Steve Basic Architect. Yes, I'm a contributor to the Build Show. If you haven't heard, Build Show is going to have a Build Show Live. Yes, we are going to have our own conference in Austin, Texas, November 7th through the 9th. So save that date, and hopefully I get to see you in Austin. Of course, all of this is happening on the Vibe board, but if you're looking for more from me, Instagram, LinkedIn, Facebook, TikTok, and of course, you're here on YouTube. Smash that subscribe button. Until next time, you know it. I'm Steve Basic Architect. Long live our buildings.